Welcome to this second tutorial on differentiation. In this tutorial we will explore the product rule and have a look at an example of the product rule in action. So just to remind ourselves, you would have covered this in class, but the product rule states that if I can express my original function in terms of two other functions, in this case u and v, where both of those functions are a function of x, then I can apply what's called the product rule, where we multiply one part by the derivative of the other part, so in this case u times dv dx, and then vice versa, so plus v times du dx. So that's what our product rule states. So let's have a look at a bit of an example. So I'll just get a bit of a clean page happening here. So we might have a look at an example here. We'll use the function y equals x squared multiplied by the square root of 3x squared minus 2. So we've got our function there, and so our product rule says that we need to be able to clearly see those two parts separated only by a multiplication sign. So what we do in our question is we define some new variables. So I'm going to let, and I like to use p, and the reason I use p and not u is because my u's end up looking like v's and vice versa. So I like to use p and q. So I'm going to simply define those terms. So I've got p is equal to x squared and q equals the square root of 3x squared minus 2. That means that now my function is y equals p times q. There's nothing else in the function that I've left out. It's all there in what I have defined. Now, setting out is really important when you do the product rule and also with the quotient rule. So defining things on the left hand side, and then what I like to do then is to calculate the derivative on the right hand side of the page. So I'll do that right now. The first one is nice and easy. So dp dx is equal to 2x. And in the second case, for some people we might need to be thinking of that function as 3x squared minus 2 to the power of 1/2. So that helps us in the way that we think through the derivative. So dq dx would be equal to 1/2, rewrite my bracket, to my new power, and then I multiply by the derivative of inside the brackets. And if you've forgotten how to do this, then you need to just revisit the tutorial on the chain rule, and that will clear it up for you. So I can multiply the 1/2 by the 6x, so we get 3x outside of 3x squared minus 2 to the negative half. I'm going to leave it as negative 1/2 instead of writing it as a square root function, and you'll see the reason for doing that. So I've got my function y is equal to p times q, so I can now set out my derivative. So therefore dy dx, so let's just write our rule out, p times dq dx plus, and I like to make a big plus sign, and the reason for that will become apparent in a second, and it's q multiplied by dp dx. So we've got our rule. Now if we've set our work out well, we should be able to pick up each component. So there's my p, there's my q, there's my dp dx, and there's my dq dx. So it's just a matter of picking up those components and popping them into the expression. So we start with p. So p was equal to x squared. We have to multiply that by dq dx, so I read over to the right hand side of the screen, find dq dx, it's equal to 3x times by 3x squared minus 2 to the negative 1/2. Put in place my big plus sign, which psychologically really separates the expression for me. So that's a massive help to me when I'm going to factorise this in a moment. Now q is equal to and I'll use the form of the equation that I've got above there with the power of 1/2 rather than the square root sign, times by dp dx, which is the 2x. Now when you get to this stage, you have essentially found the derivative. So you are correct at that point. That is the derivative of that original function. What we do from here on in is simply a case of tidying up the function. So what I'm looking for is I'm looking on both sides of that big plus sign. So you can see I've got one term here and another term there, and I'm looking at each of those terms and I'm trying to find common factors. So let's just see if we can do that. So I'll use a blue highlighter pen. I can see that this term on the right hand side has an x, and if I look on the left hand side, there's also an x there. So that's a common factor that I'll be able to pull out the front. If I use a different colour now, I'll go to my green. We can see also that this bracket here has a 3x squared minus 2. It's got it to the power of 1/2, and the other bracket has a 3x squared minus 2 to the power of a negative 1/2. So I've got some common factors. So I'm going to now factorise my expression by taking those common factors out the front of the expression and then writing what is left behind. So let's start with that x, and then we open up a bracket, 3x squared minus 2. Now we have to make a decision here about what power we take out. So let's just go back. We've got a power of a negative 1/2 and we've got a power of 1/2. Now what we do is we take out the smaller of those two powers. So in this case, the smaller of the two powers is the negative 1/2. So that's the power I'm going to take out of the bracket. Open up a nice big square bracket so that you can keep everything clean and tidy. And now you're looking at what is left behind. So if I look on that left hand side of that big plus sign, you can see that I've taken the x out and I've taken the 3x squared minus 2 to the negative 1/2 out. That leaves me with a 3 and an x squared. So I'll just circle those. So those two things there have not been taken out the front. So let's put them in the brackets. So we've got 3x squared and everything else is gone. So now I can put my plus sign in place, still making it a little bit oversized. And I look at the right hand side of the expression. Now here I can see that I've still got a 2, I'll circle that 2. So we've still got a 2 that hasn't been taken out the front. The x is gone, and 3x squared minus 2 has gone out the front, but the power was negative 1/2, which means that there is still 3x squared minus 2 to the power of 1 left behind. So what we do there, I'll just quickly recap on that. If you multiply this 3x squared minus 2 to the power of 1 by the 3x squared minus 2 to the negative 1/2, if we multiply those together, we can see that we would need to add the indices, which would take us back to the power of 1/2 that we wanted to. So we've got the correct number there. Should always be to the power of 1 inside that bracket, otherwise you've made a mistake with your derivative and you need to go back and check. Now the stuff that I have outside the big square bracket is essentially okay now. I'm going to keep it pretty static, that is I'm not going to change it too much, except I am going to take that 3x squared minus 2 down to the bottom line because it's a negative power, and it is a power of 1/2, so I'm going to make it under a square root sign just to tidy that up. Now inside the square brackets, all I am doing is expanding that second bracket and simplifying. So I've got 6x squared minus 4, and I can see now that I've got a 3x squared and I've got a 6x squared, so I can actually add them together, give myself a bit of space. So that's going to become 9x squared, take 4 inside that bracket. Okay, and that means my final derivative is equal to x over 3x squared minus 2 under a square root sign multiplied by 9x squared minus 4. And you may see some textbooks take that a little bit further because we do have the difference of 2 squares here in the brackets, so some textbooks may take that a little bit further, but essentially you've tidied it up and that's really as far as you need to go. That's a nice neat expression. We could rewrite it, and I'll just rewrite it for you. We could rewrite it all on the top line of the fraction, so x multiplied by 9x squared, take 4, over the square root of 3x squared minus 2. So it could be written like that. So again, let's just quickly go back through the process of finding our derivative from a product rule. Very important that we define the 2 parts of our function. So we've got a part there that's x squared. We've got another part which is the square root of 3x squared minus 2. So we set up some names for those. And in this case we've called them P and Q. Over the right hand side we calculate the derivatives of each of those separately. Keep it nice and ordered. You might like to use a red pen to underline your final results. You might just go something like that and underline where you get each of your results, because then when you write your your product rule out, and there's where I've written my product rule, it's just a matter of looking back and piecing it together. Final step in the process then, once you've written all those down, is that process of factorising. I won't go back through that now. I would encourage you to replay that part of the video if you're having any difficulties with the factorisation and the algebra involved there. Good luck. Hope you go well with this type of problem.